so much for joining me today. I appreciate your taking the time to come to my presentation. I know that there are other presentations that you could have gone to now, and I will try to make it worth your while. Let me just say at the outset that I don't know how the rest of you feel, but as much of an introvert that I am, it is fantastic to be at an in-person event. So the title of my talk today is Building a Distributed Data Store in 8 Weeks. And if you had a chance to look at the abstract, what I want to share with you is an experience that I had last summer mentoring a group of 4 students in a university summer project with the very vague and open-ended topic of distributed systems. And so I want to give a little bit of the background as to how this came about and how I got involved in this project. So around a year ago, March, April of 2021, I was contacted by a friend of a friend. And this friend of a friend happens to be the head of a computer science department at a university in New York called Yeshiva University. And he was putting together a summer course for very motivated students who wanted to take an elective that would give them the opportunity to learn about distributed systems. And he was contacting industry experts to see if they'd be willing to mentor a group of 4 university students in a project of my choosing. Now, once you're called an industry expert, it's hard to turn down that offer at that point. So that was certainly one of the many factors that went into my decision to go ahead and do it. I, in any event, have a great interest in mentorship and teaching. I have a number of years under my belt in the industry. At this point, when you get to my age, we call it experience and maturity. But it was something that I wanted to have the opportunity to give to these students. And also being able to craft my own project that I was sharing with the students that they would work on was also pretty attractive. Now, as you could think about it, it's a bit of a blessing and a curse, because the great news is that I can develop my own course that I want to, or the own project. But the downside is that's a lot of work. The other interesting aspect of it, and I asked the head of the computer science department, was, well, how are they going to be graded on this? If I'm going to be working with them the entire summer, how are they going to be graded? And he said, well, you're going to give them a grade. And I said, well, great. If nothing else, there'll be an opportunity for me to earn a little bit of extra money on the side. Just kidding. So first task I had is I had to figure out what kind of project I wanted to work on with these students. Now, I work at Elastic. I'm a principal software engineer at Elastic. And this is tremendous fodder for a distributed system. After all, Elastic, which is the makers of Elasticsearch, is a distributed system, and it's got a lot of meaty parts and a lot of meaty subjects when it comes to distributed systems. You've got multiple nodes. You've got coordination among the different nodes in the cluster. You have primary nodes. You have replicas. You have replication. You have sharding. So there's a lot of interesting topics that you could choose from this. So I made the decision that we're going to choose to build a distributed data store. So I put together the following blurb, which you can read here just as easily as I can. But when I initially put together this blurb, and if you've ever put together an abstract for a presentation, for example, you know that you put together the abstract well in advance of fleshing out the entire presentation. And so too here, I had some grandiose thoughts as to what we were going to cover, CAP theorem, and all those great stuff. And so I included some of those things about consistency, availability. Now, when I actually went to fully flesh out the project, it turned out that these are really hard things to work on in a concrete project. Now, one of the things that the head of the science department made very clear is that at the end of the project, there should be something very concrete, something, a deliverable, something that they can share. And I should have mentioned one of the reasons for putting together this summer project was they wanted the students to have an opportunity to see how it is out in the quote-unquote real world. They're ensconced in academia and kind of classroom projects, but how does it work? How do you work as a team if you're out in kind of an industry? And that was specifically why he was reaching out to people who were in the workforce to give them a taste as to what it's like. All right, so the next slide, I want to show you, these were the 4 students who were assigned to me to mentor for the entire summer, and I put them on the board especially. If you are looking for any interns, these would be some fantastic candidates. As I'll discuss in greater length, the amount that they were able to do in 8 weeks was astounding. I mean, it was incredibly impressive. And if Elastic had a good program for kind of summer internships, I would grab them up in a heartbeat. But they would deserve a tremendous amount of credit for the work that they put in. Now, I should mention also that they were working on this 8 hours a day, 5 days a week. So this was their sole summer project and sole summer endeavor. So they were completely focused intensely on this project. All right, so let's move to a little bit to how we worked through the project and how we structured ourselves. Now, keeping in mind that I wanted to give them a little bit of a real-world type of feel, I set it up in the way in which we might work on an everyday project at work. So I set it up with stand-ups every day. So we'd meet for 15, 20 minutes, talk about where we were, what are we blocked on, what are we doing next. And then once a week, scheduled a meeting for at least an hour where we might dive into something that was a little bit more in-depth, that required more discussion. We set it up via Slack. We had a Slack channel so we could have quick conversations. Anybody who's on Slack knows that sometimes those conversations turn out to be not so quick. And we might head over to a Zoom channel if need be. What was interesting also is because this was during the summer and also still in the middle of the pandemic, everybody was distributed. Now, these students are all based in the New York area. I'm in Atlanta, but they were also working out of their home, and so everybody was distributed, and that presented some interesting challenges and also opportunities, as we'll discuss. By and large, all the work was done together. What I mean by that is that the 4 students worked on the project together. As we'll see, that was a bit of a blessing and a curse also, and provided some feedback for me if I'm going to be doing this in the future. And then finally, and I think one of the most interesting aspects is that we worked on GitHub. And so we had pull requests, we had reviews and comments. I'd provide some comments, and then they would respond to it, try to address it. And one of the interesting things is that sometimes they were able to justify their particular strategy or a decision they made, and I conceded, you know what, you're right. Your solution is actually a better solution. So I think that was a really interesting experience also. So at the outset, these were some of the technologies, just kind of baseline what I selected out of the box. Now, I will say that I wanted to give the students a fair amount of autonomy and freedom in terms of what decisions we made, but there were certain things that I had to put guardrails around so that we didn't get too far afield and we didn't go down a rabbit hole. So we're going to build a REST application, so it was REST heavy. And I chose Spring Boot as kind of the underlying structure or the underlying framework for this project. Now, whatever you think about Spring Boot, one thing is it's very easy to get started. Knowing that we only had 8 weeks, I didn't want to spend half of that time building out a whole REST framework. So I wanted to be able to get started very easily so they'd be able to get up and running so that we could get into some of the distributed topics. In addition, I chose H2 just because it's such an easy database to get started with. GitHub, as I mentioned, and then everything was done via Postman, all the API client operations. So in order to get started, now I didn't know what these students knew, what their level of expertise was, and what I quickly found out is that although they were very motivated, their knowledge was also fairly raw. And I had to kind of go into really the basics of what is a REST application, the CRUD operations, and in addition, very basic relationships in a SQL database. So we built a very simple, and I use that word advisedly, simple application which has a book, stores a book, and a bookstore. So you've got a bookstore which can have many different books, and you can have multiple bookstores, and you have a relationship between the book and the bookstore. And then mapping all the CRUD operations to the HTTP verbs, kind of basic REST type of strategies. And all this was fairly new to the students. And so if you can imagine, I mean, these are the type of things that when we've been working in the industry, we have assimilated over a fair amount of time, and now they are being thrust all at once with all this information about relationships and about REST and CRUD and all that. They were able to pick it up very quickly, and by the end of the first week, they had a very basic web application which served up books and bookstores. Now, what was interesting, I say simple, but when you're starting from scratch, it's not simple at all. And that was one of the, I guess the messages is, and I'll delve into this a little bit more later, but just taking information and taking the knowledge that those of us who have been working in the industry, taking it for granted. And for them, this is not for granted. They're coming with very fresh eyes, which I found very appealing to a large degree. So like I said, by the end of the first week, we had a basic CRUD, and this would be kind of the baseline and the foundation for building up to a distributed application. At this point, we don't have a distributed application. All we have is one single server serving up this data. Now, one thing I'll just mention is that all this was done just via API. There was no front end, there was no UI or no GUI. And the reason for this was twofold. Number one, I'm just a back-end guy. I don't delve much into the UI, so this was just something that was a lot easier for me to handle. But even more importantly, I wanted them to take an API-first approach to kind of see how information is delivered to a client. Too often when we are introduced via tutorial where you develop the back-end and the UI at the same time, it's very easy to couple those two together. And I wanted them to think about it independently. So all of the client operations took place via Postman. So the next thing that I did was I challenged them, and I said, okay, we have this data, we have this bookstore, works, everything's great. Imagine if this becomes incredibly popular, and now we've got this bookstore, this web application at scale. What are some of the problems that we could have? They went ahead, took a day or two. I told them to think about it, write down all the issues that they could come up with. This is a very interesting exercise, and you think about what would I come up with if I was doing this. And again, this is kind of where the taking knowledge for granted comes into play, where they're coming with fresh eyes. They've never worked with things at scale before. And so it was very interesting to see the kind of problems that they came up with. Now, if you take a look at this list, slightly edited, there's also a bit of overlap, but it's a very interesting list, and I have to say it's quite an impressive list of things that they came up with. You see that there's server crashing because of the load maybe, or because we're running out of data. We could have potentially malicious actors that are corrupting data. What I thought was really interesting is they came up with, well, you could have inconsistent state of shared data, because if you have data distributed between systems, what if that data isn't synchronized? That's a very valid point. So those were the things those were kind of lists that they came up with. The next thing that I challenged them with, all right, now come up with some solutions. I want to see what they would come up with. And again, I think that this is a very interesting exercise just to ask ourselves, the amount of time that we've been in the industry, what would be our solutions? So one of the first ones they come up with is, well, each bookstore could have its own dedicated server. So we're already thinking about kind of partitioning here. And they brought up a virtual private cloud. So they had been introduced to some concepts in the cloud, AWS, and so they were familiar with that term, and they were able to kind of associate it. Well, maybe that would be helpful here. And we talked about, well, what problems might that solve? Well, it somewhat solves the server crashing issue, okay? Because now you've got the load that is distributed amongst different servers. Makes sense. somewhat solves inconsistent data, kind of depends on how we're going to partition the data. Bad actors to some extent, certainly cuts down on the traffic. And we've got more disk available. So again, it's just a very interesting exercise to see what they could come up with. In addition, somebody mentioned, and I guess they had taken a database class or some sort of data store class, they came up with a RAID system where you have multiple drives. Part of the data is on different servers. Again, this idea of partitioning the data, which is a very important part of distributed systems. And then we spoke about some optimizing database for our use, having a LRU cache. We could have something in front which caches data, pre-construct SQL calls, and then kind of the trade-offs and downsides, which are complexity. And this is one of the important messages that I wanted to convey to them, is that everything is a trade-off. And especially when you're talking about distributed systems, whatever decisions you make, these are going to be trade-offs along the way. And then what we also talked about, which we decided was out of scope, was an authentication, authorization system, so that we could try to prevent malicious actors. Now, what this exercise also provided us was kind of a little bit of a path forward. Like I mentioned, I wanted to give them some autonomy and some decision-making in terms of what path we would go along and what areas we would explore. With only 8 weeks, there'd be a limited number of topics that I could really explore. All right, so before we got into really the meat and potatoes of distributed systems, I wanted to introduce them and make sure that they understood the difference between scaling vertically and horizontally. Because before we can discuss what are the challenges and what are some of the topics around scaling horizontally, which is really what distributed system is, if you can throw hardware at the problem, well, that's your first choice. If you could throw money at the problem, maybe that could solve your issue. Because while distributed systems and breaking apart into different servers and different nodes, while that may solve some problems, it also introduces a whole bunch of other sets of problems. And so if you can avoid it, maybe that might be your best option. Be that as it may, we then got to talking about, okay, now that we've settled that we are going to distribute our system, there are really one important axis and decision point, and these are not mutually exclusive, of course, but there are two very important points in terms of distributed systems. One is replication, and the other one being sharding and partitioning. And we discussed, well, what does replication accomplish? You have data now in multiple places, and different strategies. You can have master-master, master-slave. And then we talked about partitioning, where you have your data that is partitioned in different servers. Now, this is one of the areas where I had to step in and kind of set the stage for what we were going to do next. It turns out, if you've tried to do any sort of pet project with replication, it's a really tough problem. And it's very hard to kind of get something out in a few weeks. I mean, you've got problem with write-ahead logs, catching up, ordering of events. Those are all really hard problems, and nothing that I felt that we could solve concretely within 8 weeks. So I said, we're going to focus on partitioning, sharding. That's where we're going to focus our energies. And now that our bookstore, our web application has become very popular, how are we going to partition the data? So at this point, we had a couple of different decision points to make. And what I told them was, I want you to decide how we're going to partition and shard the data. And we talked about different strategies. But what I made clear was it has to be consistent and predictable. Because if you need to know how to store the data and then where to retrieve the data from. And so it has to be predictable and consistent. And we discussed various options. You could use a key. You could do it by hashing a book title, book ID. There are various strategies. And what they came up with was, well, we think it makes the most sense to shard by bookstore. It's a very logical, very sane approach, is that they're going to shard, they're going to have one server per bookstore. Now, we also talked about potential downsides, because if one bookstore happens to be much more popular than the other ones, well, you're going to have all the load going to one bookstore. Again, trade-offs. You got to make a decision about how you're going to partition the data. And they felt that given all the different variables in the equation, partitioning by bookstore made the most sense. Said, great, let's go with that. What I next told them is, okay, part of the requirements is that this needs to be client agnostic. What that means is a client has no idea which IP address is serving which bookstore. All it knows is maybe it got a couple of IP addresses, and it wants to add a book from a particular bookstore or retrieve a book, and it could go to any of the bookstores in the cluster in order to do any of the operations. So the client should have no special knowledge about the bookstores. Now, I have to say that some of these requirements and examples were somewhat contrived. You're always going to have that in any sort of project. But I wanted to give them a taste for the type of problems that they're going to encounter when they go into the workforce. And having a client-agnostic type of strategy is very common. So what does this introduce? Well, we've now got to think about server discovery. How does bookstore A know about the other bookstores in the cluster? And what I told them is, we're not going to hard code anything. We want to make this dynamic. Again, I want to give them a nice meaty problem to chew on. So I told them, go think about it, and how are you going to solve this? How are you going to make sure that bookstore A knows about bookstore B, C, and all the other ones, and know how to reference them? So we've got to know what the IP address is. So they went back and thought about it a little bit, and they came up with the idea of a hub. This was their terminology. They called it a hub. I think it's a great idea. The hub has its own database, and the hub is kind of the coordinating. It's a separate app, separate running process, I should say, which is kind of the coordination between all the different servers. Now, again, this is time to stop and think. How would you solve this problem? What would have been your solution? Now, I would have said, I've used Zookeeper in the past, so I said, oh, that's a great solution. But I thought that this was fantastic. It would give them an opportunity to see some of the problems in building a kind of a coordinating process. So they've got a hub, which has its own database, and when each of the bookstore's servers come up, they register with the hub. So they register themselves, provide the IP address of how they can be located, and the fact that they exist. The next part is, the hub then propagates that information amongst all the different bookstores. So now each of the bookstores has a table of, here are all of the nodes in the cluster, here are all the bookstores that are in this entire ensemble, and here's how to reference all of them. Fantastic. We now have a coordinating service called the hub, which allows each of the bookstores to have knowledge about the other bookstores. So this is kind of our bootstrap mechanism. Thought this was a fantastic idea. So then we said, okay, let's go through different operations that could occur in this cluster. The first thing we start with is, let's have a very simple operation. A client wants to read a book. Again, client agnostic is part of our requirement. So the client doesn't necessarily know which of the servers to go to. It just knows it wants to get, if you start from the left here, it just wants to get a list of books from bookstore C. So it's got the IP address of bookstore A, and it says, hey, bookstore A, give me all the books from bookstore C. How do you do that? How does bookstore A tell the client, I don't have that information, but bookstore C has that information. Let me tell you how to get there. And again, this is kind of a pretty common problem that you encounter in distributed systems. Redirecting or referencing a different cluster, or a different node in the cluster. So I introduced them to the concept of a client redirect. Again, they had no knowledge of any of these HTTP verbs, but what I wanted to do is to abstract it a little, that this is really a pattern in distributed systems where you're placing a little bit more of the burden on the client. So bookstore A will respond with a 301, which is a redirect, and because it knows where bookstore C the IP address, it can say, here, go fetch the information from the other bookstore. So in this case, we're taking the kind of the burden away from the server and we're placing it on the client. So this is one strategy that we can employ in a distributed system to give the client the information that it needs. Okay, next strategy that we take a look at is, well, how about if we have information that is spread amongst the different bookstores? So for example, we want to get a list of all the bookstores. Or maybe we want to get a list of all books across multiple bookstores. Well, the client redirect won't help in that case because the data is spread out amongst several different servers. So in this case, we introduce the pattern of a server forward. So in this case, the client will go to any of the bookstores. It'll say, give me a list of all the bookstores. And bookstore A then has to go to all the other bookstores to get information, and it's got a list of all the other bookstores during the registration process with the hub. It can then collate all the information and return that to the client. So in this case, we're taking the burden off of the client and we're putting it on the server. And we discussed, again, trade-offs. There are trade-offs to putting the burden on the client versus on the server. Sometimes one approach might be appropriate, sometimes another approach might be appropriate. And there are pros and cons. There's no right answer, which is one of the things that I really wanted to impart to them, was that there's rarely a right answer. There are choices and decisions to make. I want to stop for just a moment and interject with something that I also found very interesting in terms of the way that they worked. As I mentioned, all these students were distributed in different parts of the New York area. They were not co-located in the same place. Now, how would you test a distributed application? The way I would do it, and again, this is kind of like where you have these preconceived notions and you take information for granted, I probably would have spun up some Docker containers or running on different ports on one machine. And that's the way I would simulate a distributed application. Now, they're coming with fresh eyes. They said, well, we're distributed. Let's run our applications on different, each one of us will run one of the servers. So one person will run the hub. One person will run server A. Now the question is, how do you communicate? Because you've got NAT in the way and all those other various network things. So the first thing they did, which was pretty ingenious, I think, was to try to set up port forwarding on their routers at home. That worked to some extent, but it wasn't great. So I introduced them to ngrok.com, which is kind of a ngrok online. You run an ngrok process locally, and it communicates something in the cloud, and you could see all the traffic kind of going forward, or all the traffic going between the different servers online at the particular URL that they give you. So what they then were able to really simulate was they were really running a distributed application. So they encountered some latency between the different servers, which was really interesting to see. And again, I think what I learned from that was, seeing it from fresh eyes, they probably had a better simulation of a distributed application than I would have come up with on my own. So this was kind of neat to see how they thought through simulating and working through a distributed application. Okay. Going back to the different operations I want to introduce them to. So we discussed the read operations. Now, let's take a look at write operations. Well, if we need to make a write to a single bookstore, we've already got a pattern for that. We could use the client redirect so that if the client makes a request to write, to post a book to bookstore C, A can tell the client, hey, I don't have that information, or I'm not the right location for that. Go to bookstore C. So far, so good. Here's where it gets interesting, though. Let's say you want to post a bunch of books. And let's say that you've got multiple clients that are posting potentially conflicting data about similar books. Well, what you could end up with here is inconsistent data. If we were to use the approach that we had before of server forwarding and allow any of the servers to handle these batch requests, you could end up with inconsistent data, where one of the writes is stomping on the other right. Now, I do need to stop. Some of you may be thinking, well, wait, if you're using a database that's ACID compliant, that's very unlikely. Granted, again, some of this is somewhat contrived, but what I really wanted to show them is when you have multiple writes coming at the same time, you can run into a problem of inconsistent data, shared writes. So what I wanted to introduce them, and this was another important kind of topic that I wanted them to assimilate, was that problems in distributed data often have analogous to problems that you have in a single application running on a single machine. Now here we have an example of where you have shared data and you have multiple things writing to it. That sounds like multiple threads writing to shared data. This is a much more approachable problem than thinking about different servers. And so if you've ever worked with multi-threaded applications, locking, synchronization, I mean, this is part and parcel of what we do every day. So I wanted them to think about, well, how would you solve that if it was just one application? And then we could build that out to a possible solution in a distributed system. Well, the way in which one of the primary ways that we deal with that in a single application, share data amongst threads, is we'll use something like a read-write lock. And what a read-write lock allows us to do is we could have multiple readers, but once something wants to come and write, there's only one thread that can write to that data. So this is, again, a solved problem, if you will, when you're talking about one application. So how do we kind of take that into the macro level? Now that we have a distributed system, how do we employ the same sort of strategy? We discussed this a little bit. What I introduced them to was, well, this is where leaders come in. So if you have multiple nodes in a cluster, and you have write that might encompass all the different nodes in that cluster. Again, using that analogy, if you think about these as different threads that might be writing the same data, we've got to make sure there's only one server that can handle those write operations. So in this case, we have multiple clients. The client on the right says to Bookstore C, hey, I want to post a batch of books, and this is going to involve multiple servers. Bookstore C says, I'm not the leader, I'm sorry. I'll tell you who the leader is. Go to Bookstore A, and you'll be able to post all of your books there to do a batch operations. And then we could do a server forwarding, and we'll be able to avoid any inconsistent data. So fantastic, we've got a solution to our problem as to how we're going to coordinate the writing of this batch operation. But how are we going to choose a leader? So this is what I challenged them with. And they said, well, wait, we've already got our hub where we have server registration. We can use the hub for leader election also. I said, great, that's a brilliant idea. So now part of the registration process is all the bookstores register with the hub when they come up. The hub distributes the information to all the servers, and now it does one more thing. It elects a leader randomly amongst all the bookstores. So now, in addition to the IP address of all the other nodes in the cluster, also gives some information about who the leader is as well. I said, okay, great. That's a great solution, works. They implemented it. I said, let's say bookstore A goes down. What do we do then? Now we got a problem because there's no leader to handle these batch operations. So they thought about it, and what they come up with was we could do health checks periodically. Brilliant. So every once in a while, every 10 seconds, let's say, the hub will check to see is bookstore A still up, and so they implemented a endpoint on bookstore on each of the bookstores, a kind of a health endpoint. Say, are you still up? And if it's not, then the hub will elect another leader. This is great. I mean, seeing it in action and seeing this is kind of a known strategy and pattern in terms of distributed systems was fantastic to kind of watch how they were developing this iteratively and in real time on their own. Okay, so fantastic. Now we've got a fully fledged distributed system. We've got multiple servers communicating with each other. We've got a hub for coordination. It's all working great. Next thing I wanted to introduce them to was resilience and fault tolerance. So let's say that there's a flaky server calling up and down, and we've got communication going on between the servers, also between the hub and the servers. So what happens if something is a little bit flaky? So the first thing is we could do a retry. Now for this, I introduced a library called Resilience4j, which has got some nice facilities for handling these type of things. So with a couple of annotations, we can have some retries so that if server is kind of going up and down, we'll be able to retry. We took it up a step, introduced circuit breakers. If you're not familiar with circuit breakers, basically it's where if you have a communication pattern between one server and another, and the other server is not responding after a certain number of tries, then the first server won't even attempt anymore until there's a certain period of time. So it might wait a few minutes before trying again. That way we're not wasting resources. And what we also introduced here was the concept of a fallback. So what happens if server A needs to get information from server B? Server B's down. Retries a bunch of times, still nothing doing. So what does server A do? Does it return an error? Does it just not include the information from server B? So again, we got a few different choices, and we talked about implementing a fallback in that case, that we can't get all the information from all the servers that we need. And then finally, we talked about throttling or rate limiting. So you may have malicious actors or even just bad programmers that are constantly, you may have clients that are constantly trying to get information from the bookstores. We want to prevent a DDoS attack, try to prevent our servers from going down. So we can introduce throttling or rate limiting into the equation as well. So this was another topic that we had an opportunity to introduce and for them to kind of sink their teeth into. And then finally, maybe the final topic that we discussed was distributed logging. In a distributed system, one of the hardest things to do is to debug, because you can't just follow a log in a single application and try to figure it out. Now, even in that case, as we all know, it's not always so straightforward. But if you've got communication going on between different servers, the hub, the servers amongst themselves, how do you know where exactly the problem was? So I introduced them to the concept of distributed logging, and there are various ways of accomplishing distributed logging, but one of them is by adding a request ID to every request. So now, whenever the client goes to any of the bookstores, we have a servlet listener that can intercept all the requests, put on a UUID as a request ID, and then include that request ID throughout the chain of communication between the servers that might occur. So now when you're looking at the logging, you can kind of correlate the request ID. So this was another kind of tool in the toolbox. Now, as we'll see, one of the feedbacks that they gave me is, you should have told us this at the very beginning, as opposed to the very end, because it was very challenging for them to troubleshoot as they were going forward. Now, you could make the argument that had I introduced at the very beginning, they wouldn't have appreciated the value of it. Sometimes it's better to go through the pain so that you can then see what the solution provides you. Any event, that was one of the main topics, or one of the last topics, that we discussed in our distributed application. At the very end, I wanted to just go through a few topics very quickly, and there's no way that I could have done any of these justice, but I wanted them to at least be familiar with these. Again, there's only so much that we could have covered in 8 weeks. So one of the first things that we discussed is the hub is a great solution to the problems that we discussed. However, we do have a single point of failure. What happens if the hub goes down? So now we have to now distribute the hub. But now we have kind of a chicken and egg problem, because how do we have coordination among the different servers that make up the hub? So we didn't get quite to answering that question, but I at least wanted to get them thinking that in some sense, they have kind of pushed the problem down the road of coordination between distributed systems. That led us kind of in a natural discussion about some consensus algorithms, Raft, Paxos, Zab, which is used by Zookeeper, this is a known problem and there are solutions. They're complex, but there are solutions for getting a consensus in distributed systems. Talked about transactions, repartitioning data. Let's say that a bookstore closes, or let's say two bookstores were to merge. What do we do with the data amongst them? And again, these are wide topics that really require a lot more discussion. Docker, just because it's a big thing. Authentication, authorization, different messaging patterns. I mean, everything that they did was all HTTP because it was a paradigm that they understood. But we also talked about, like using something like Rabbit or some other messaging protocol, asynchronous versus synchronous communication. And then one of the things that they really wanted to try, and I don't know if they ever got to it, was building a UI for this. Like I mentioned, everything was kind of driven by Postman and via client tools. Now, for just a few minutes, we still have a few more minutes, one of the deliverables that they had to have, now they had a GitHub repository where this was all shared with the head of the computer science department and with some of their fellow students. But what they also had to do was they had to put together a video demonstrating what they had accomplished over the summer. Now, I thought that I would take it up a notch. And what I did is I included several of my colleagues at Elastic to sit in to a demonstration, and would also give them an opportunity to field questions from my colleagues. Now, although this would amp up the pressure, I thought that this would also give them an opportunity to kind of, number one, shine, but also be subject to some, maybe some hard-hitting questions and see how they would field it. That turned out to be a very successful thing. Now, if I can get this to work, I just want to show you, I'd love to show you the entire video because I think it was fantastic, but I want to give you just maybe a bit of a highlight here. Let me start at the beginning.
Hi, I'm Yoel Spotts from Chicago, Illinois, and I'm a first-year computer science student at Yeshiva University.
I'm Benjamin Jacker from Teaneck, New Jersey, and I'm a second-year comp sci student.
I'm Seth Jacobs from Burgerfield, New Jersey, and I'm a second-year computer science student.
I'm Jonathan Olsen from Woodmere, New York, and I'm a second-year CS student.
This summer, we participated in the Industrial Software Development course offered by Yeshiva University,
where we had the opportunity to learn from expert mentors,
work as a group,
interact with technologies we have never seen before,
and developed our first distributed system.
Yoel Spotts worked with us this summer as the mentor for this project.
Yoel lives in Atlanta, Georgia, and is a senior software engineer for Elastic.
He consistently challenged us and helped direct the development of our application.
We're extremely grateful for all of his help.
Over the course of the summer, we built an application for a distributed bookstore. A bookstore has a repository of books on which the CRUD operations can be performed. You can create a book, read the information of a book, update the information of a book, and delete a book from the repository. The repository is persistent, and the inventory gets saved to disk even upon shutdown. To partition the data evenly, we have one bookstore per server in the network.
I'm just going to skip ahead now to the parts of the demo.
In 1917, in New York City, Gilbert Clifford Noble and William Barnes became partners in their first bookstore. Located on 15th Street, this small store quickly became a staple of the community. This store would have needed a way to keep track of their inventory, and our software would be perfect. Using Postman, we'll create a bookstore representing the small shop on 15th Street. So as you see, Seth has all the information ready to go, and he's now going to post it to his server. If you notice, the JPA repository auto-assigned him the server ID of 1. As the store grew more popular, they had to add more and more books to their inventory. For example, The Great Gatsby became very popular upon release in 1925, and any bookstore would have needed to stock it. so Seth is now going to post it to his newly created bookstore. As times changed and inflation hit, the price went up and therefore needed to be updated. Seth is now going to demonstrate updating just the price of the book. As you can see, the only thing that's changed is the price. After facing challenges from Baptist groups, The Great Gatsby was temporarily removed from bookstores and therefore needs to be deleted from our inventory. As you see, Seth successfully received the 204 status code indicating that it was deleted. As the bookstore grew, customers requested the ability to browse through the ever-growing inventory. Seth is now going to demonstrate getting a collection of all the books stored in his store. As you can see, he has 1984 by George Orwell, as well as The Way of Kings, and finally, Charlotte's Web. In 1932, at the height of the Great Depression, the bookstore moved its flagship location to 18th Street and 5th Avenue, the place it would stay until it closed in 2014. Seth is just going to demonstrate updating one part of the information for the bookstore itself. As you see, the only thing that's changed is the street address.
In the 1940s,
So I'm just going to move ahead to the question and answer forum, just some of the highlights there.
I should have done that. Like, this is going to be my next step. Like this. So I'm super curious. Whenever I build something like this, like there's always like a long list of stuff where I'm like, oh, I should have done this. I should have done that. Like, this is going to be my next step. Like, this is going to be like the next thing. Like what are some things that y'all were sort of like, yeah, we'd love to add this, but like just don't have time or it's not in scope, or like, you know, if you're going to extend this, like how would you extend it? Like what's any thoughts on that? Is that too general of a question?
No, that's a great question. We know our point of failure is really at the hub, which it's true that the basic network already will stand and can stand on its own while the hub is down. But if the hub does go down, as we mentioned, there is no way for new servers to be added, nor can they even restart, because a part of the restart is they reclaim the map of the network from the hub. So we would have to do some kind of redundancy or some other way for them to be able to find their way to the network if on restart about the hub. So we know that that's our main point of failure. So that would be probably something that we would want to add.
Something we also spoke about a little bit was authorization and controlling who can access and update which pieces of information. So that would be really great to add to the system.
Another thing which was a little further down the line, but we spoke about making a GUI last week, a graphical user interface, which you thought would be a lot cooler.
I'll stop it there, but I just wanted to give some of the highlights. The part that I was really impressed with how they came up with the whole story around what these bookstores, and when they added new bookstores, they had introduced the hub. So they put the whole narrative around it and they scripted it all. I just thought it was incredibly professionally done, and they really outdid themselves, in my opinion. So to kind of wrap up, I wanted to share some of the lessons that I learned. Can't speak for what they learned, but some of the feedback that I got for them. The first one was just how impressive it was what they were to accomplish over the course of 8 weeks. Now again, if you think about where they started from, not knowing what a REST application is, very limited knowledge about relational databases, and then to building a whole distributed application, it's very impressive. It's also very easy to take knowledge for granted. And I say that in a few different ways. Number one is, we all know imposter syndrome is real, and it's very easy to think that what have we done over the course of X number of years in our industry? There's really a lot that we know that we don't realize we know. But the other part is, it's very easy to fall into the trap of, yeah, I've seen this before, I know exactly how to handle this. And seeing it through fresh eyes was really eye-opening for me to see how they approached a lot of these problems. And I learned a lot through that. It really forced me to organize and systematize information that maybe I knew but was kind of disparate in my mind. And it really forced me to really think through a lot more deeply about some of these things. It was a great mentorship opportunity. Also forced me to be flexible to, if they wanted to explore a particular subject, to at least be open to it, even if it wasn't always possible. It was also had to make some decisions about certain things that I couldn't cover, like transactions. So we had one problem that came up where they crossed transaction boundaries. And I had to kind of elide over that because I really didn't want to get into transactions and what does transaction boundaries mean. And I kind of had to, okay, just solve it this way. We'll talk about this later maybe if we have time. It was a lot of work. Now I'm very fortunate. At Elastic, they give us a week of VTO, volunteer time off, which is very, very much appreciated. I will say that I blew through that very quickly. It was a lot of work, but was it worth it? Absolutely. And would I do it again? Absolutely. It was a fantastic opportunity for me, and in fact, I'll be doing it again this summer with a new group of students, and I'll try to change it up based upon some of the feedback. Now, the feedback that I got was overall very positive. It was a great way to get introduced to distributed systems. It was kind of a step-by-step approach they found very helpful. Group meetings were productive. They really, really liked, it was very satisfying and fulfilling that they had something concrete that they could show off, and they could give it to their fellow classmates to say, look what I did. And then they really enjoyed being able to present to my coworkers at Elastic and be able to field questions to kind of test their own knowledge. They found that very useful. Some of the critical feedback I got in terms of, if we do it again, here's some things to improve on. It was really tough for all four of them to work at the same time. Now, pair programming is one thing. Quadruple programming is pretty tough. And so they suggested that I find a way to parallelize the work such that there could be like 2 teams of 2 working on these problems. So that's something I'm going to think about. This was really interesting from a technical perspective. They said Spring Boot was really easy to bootstrap to get started with, but then all the annotations and everything, it just seemed like magic after a while. Now, anybody's worked like Spring Boot is like, yes, exactly. But it was great seeing that kind of in real time over the course of, in little 8 weeks, they got it. So that was really, I thought that was really fun feedback. Some of the third-party libraries were a little bit challenging. Resilience for J had some sharp edges. They also suggested that introducing sockets and ports, a little bit more of an introduction there. Some of them hadn't necessarily taken networking classes. And as I mentioned, introducing logging earlier into the project, something I'm thinking about. And then they also wanted more discussion of Docker. And that's something that I really need to think through. I recognize that they want to know about Docker, but I'm trying to think through whether that would kind of sidetrack what our main goal is around distributed systems. So that's something I'm thinking through for the next for the next project this coming summer. And whenever this is posted or whatever, I share the links. Again, I would highly recommend seeing the entire video just because of the quality production that they put into it. And their project is on GitHub. There were also various other projects that other groups did that summer that I'd welcome and I'd recommend that you take a look at as well. So that's about it. Thank you very much, everybody. Appreciate it. I'm happy to, I think we're right up against time. Yes, we're actually over time, but I'm happy to stick around on the side or what have you and field any questions that you might have. Thank you very much and enjoy the rest of the conference.